Namaskar, my dear friends. Welcome to the lecture series of computer-aided manufacturing. In our previous video, you were learned about the constructional detail of CNC machine, okay, and recirculating ball screw. Okay. Now, today in this lecture, you are going to learn about the fundamentals of part programming. Now, let us start with the objective of this lecture. The objective of these lectures are the basic principles of manual part programming, the use of various codes in part programming, and how to develop part program for various jobs. Okay. Now let us start with the introduction of the part programming. So the part program is an important component of CNC system. Okay. So a group of commands given to the CNC for operating the machine is called the program. The shape of the manufactured component will depend on how correctly the program has been prepared. A part program is a set of instructions which instruct the machine tool about the processing steps to be performed for the manufacturer of a component. Okay. So part programming is the procedure by which the sequence of processing steps and other related data to be performed on the CNC machine is planned and documented. So the part program is then transferred to one of the input medium and which is used to instruct the CNC machines. Okay. So it consists of information about the part geometry. Okay, part program, it consists of the information about the part geometry, motion statements to move the cutting tool, cutting speed, feed, auxiliary functions such as coolant on and off, and spindle directions. Okay. So these are the different parts. Okay, part program will consist. Now let us start with the NC words used in the part program. So the NC word, what is it means? The combination of binary digits, that is called the bytes, in a row on the tab denotes a character. So a NC word is a collection of characters used to form an instructions. Typical NC words are X position, Y position, feed rate, etc. So a collection of NC words is called a block, and the block of words is a complete NC instructions. Okay, so the different NC words used in this formation blocks. Okay, they are sequence number, preparatory function, okay, coordinates, that is X, Y, Z, feed function, spindle speed function, tool selection function, miscellaneous function, and end of block. Okay. Now let us start with first is the sequence number. It is known as a N word. Okay. So the first word in every block is the sequence number. Okay. So the sequence number, it used to identify each block within an NC program, and it provides a means by which NC commands may be rapidly located. Okay, so it is a program line number. So it is good practice to increment each block number by 5 to 10 to allow the additional blocks to be inserted in future changes are required. Okay, so the sequence number is preceded by word N and is written as N 0001, N 0002 to N 9999. Okay, so the program is executed from lowest block number to highest unless the instructed otherwise. Okay, so it is customary to start with block number 001 okay, or 0010, and proceed in step 5 to 10, okay, as usual. Then next one is the preparatory function. It is known as a G words. So this preparatory word, okay, used as a communication device to prepare the machine control unit. Okay, so this G code indicates that a given control function such as G01 is linear interpolation and is to be requested. Okay, so this preparatory function is represented by 2 digits preceded by G, that is G00 to G99. Okay, so the preparatory function, it enables the controller to interpret the data which follows, and it precedes the coordinate word. Okay, so some of the preparatory functions here, they are known as the G codes used, okay, in the CNC machine programming are G00, that means the rapid traverse. G01 is a linear interpolation. G02 is a circular interpolation clockwise. G03 is a circular interpolation counterclockwise. G04 is a dwell period. G05 is a hold and delay periods. G17, that means the XY plane designation. G18 is ZX plane designation. G19 is YZ plane designation. G33 is used for the thread cutting operation, and G40 is used for the cutter compensation cancel. Okay, G41 is used for the cutter compensation left side. G42 is used for the cutter compensation right side. Then more G codes are G63 thread cutting cycle, G70 dimensioning in inch unit, okay, G71 dimensioning in metric units, G80 is for can cycle cancel, and G81 to G89 for the different can cycles. G90 is used for the absolute dimensioning. G91 is used for the incremental dimensioning. G92 is used for the zero preset. G94 is feed rate in mm per minute. Okay, value of the feed rate. If you want to give the value of the feed rate in mm per minute, then we have to use G94 code. And if you want to use the feed rate in mm per revolution, okay, then we have to use the code G95. So this is known as the preparatory function, or we can say G words or G codes. Okay, they are very important in a CNC programming. Then next one is the coordinates. Coordinates means X, Y, and Z words. Okay, so these words give the final coordinate position for X, Y, and Z motion. Okay, so in 2-axis CNC system, only 2 coordinate words would be used. Okay, so to specify the angular positions around the 3 coordinate axis, additional, that is a word and A word and B word are used. Okay, now in addition, the word I, J, K are used to specify the position of arc center in case of the circular interpolation. Okay, so different CNC systems use the different formats for expressing the coordinates of a point. In some systems, the decimal point is not coded, but the control system automatically provides a decimal point at a preset position. Okay, so but in such cases, leading zeros may have to be given in the program. That is, x is equal to 5.60 will be written as, okay, x is equal to 5.60. It will be written as x 0000560. Okay, X 5.60, it will be written as X 0000560 in a particular system where X dimension is to be followed by 6 digits, and the control system, it places decimal after leaving two least significant digits. So however, some CNC control system, it accept the decimal form. So we will adopt this convention for expressing the data in decimal form. So while giving the data, positive sign is optional, but negative sign has to be given in case of negative dimensional position. Okay, so positive data is optional. Okay, you may write plus sign or not, but for the negative, compulsorily you have to write the sign of minus or the negative. Then next one is the feed function. It is known as the F word. Okay. So the feed function is used to specify the feed rate in the machining operation. The feed rate is expressed in millimeter per minute, that is mm per minute, or millimeter per revolution. Okay, so if the feed rate is 200 mm per minute, then it will be represented as F200. Okay, so the appropriate G code, it should be specified to instruct the machine whether the feed value is in mm per minute or in mm per revolution. So as we discussed in G code, G94 is used for the mm per minute and G95 is used for mm per revolution. Okay. Then next is spindle speed function, S word. Okay. So the spindle speed function is specified either in revolution per minute, RPM, or as meter per minute. Okay, so if the speed is given in meter per minute, the control unit, it calculates the revolution per minute using the appropriate formulas. Okay, so if the machine is required to run at 800 RPM, then the speed will be specified as S800. S800, it means the spindle speed is 800 revolution per minute. Okay. Then next is the tool selection function. It is known as the T word. So the T word is needed only for machines with programmable tool turret or automatic tool changer. It is ATC. So each tool pocket on the tool turret or ATC has distinct tool number. So the T word in the part program, it specifies which tool is to be used in the operation. Okay, so the tool number for the particular operation is specified as T00 to T99. So also with each tool code, the corresponding tool length offset is also specified with the help of two-dimensional digit, that is T01.01, where second 01, it denotes the tool length offset for tool number 1. Okay, so this is the T word. Okay, so each word have specific meaning. Then let us move ahead, and next one is the miscellaneous function. It is known as the M word. So the miscellaneous function word is used to specify certain miscellaneous or the auxiliary functions which do not relate to the dimensional movement of this machine. Okay, એટલે એનો મતલબ કે કોઈ પણ આ જે miscellaneous word છે એને dimensional movement સાથે કોઈ એને relation નથી. Okay, so the miscellaneous functions may be spindle start, spindle stop, coolant on off, etc. Okay, so an example of M word is suppose M02, which indicate the end of program. Okay, so let us see different M codes used in CNC machine. Okay, these are the main miscellaneous functions. There are numbers of miscellaneous functions, but as per our syllabus is concerned, we have identified these numbers. Okay, so M0T02, that means the program stop. M03 is meaning spindle start clockwise. Okay, if you want to rotate spindle in clockwise direction, then we have to write the M03. And if the spindle uh, rotation is in counterclockwise, then we have to write the M04. That means the spindle start in counterclockwise direction. M05 spindle stop. M06 tool change. Okay, if you want to change the tool, then we have to use the M06. For coolant on, we are using the code M08. And for coolant off, we are using the code M09. And for the program stop and tap rewind, the M30 code is used. Okay. Then next, or the last one word is the end of block. It is EOB. So this EOB symbol, it identifies the end of instructional block. Now let us see some extensively used G codes. Okay, let us discuss about some extensively used G code. Okay, before that, sequence and format of the word you can see here. Okay, so first one is the N3, that means is the sequence number. Okay, N3 is the third number. Okay, then G2, okay, that means it shows the preparatory function. Okay, now here you can see this X 1.4, Y 1.4, Z 1.4. It was its destination coordinates. Okay, 1.4 plus is the X coordinate, value of X coordinate is 1.4, value of Y coordinate is 1.4. and value of Z coordinate is 1.4. Okay, then here you can see I, J and K. It shows the distance to center of circle. Okay, I, J, K. It shows the distance to center of circle for the circular interpolation. Now F it shows the feed rate, S is the spindle speed, T is the tool, and M is the other function, that is the miscellaneous function. Okay, so this is the sequence and format of words. Now let us see. First one, G00 is the rapid traverse. Okay, so when tool being positioned at a point that is preparatory to a cutting motion, to save time, it is move along a straight line at rapid traverse at a fixed traverse rate, which is pre-programmed into the machine's control system. Okay, so this typical rapid traverse rate are 10 to 25 meter per minute, but can be as high as 80 meter per minute. Okay, so all the movements in the rapid traverse are performed at the maximum feed rate available on the CNC machine tool. So which depends on the design of the machines, and the instructional block with rapid traverse function is written like this. Okay, so here N010 is the sequence number. Then this G90 or G91, it shows the absolute dimensioning or incremental dimensioning. Then G0 means the rapid traverse. Okay, then coordinates X10, Y10 and Z5. That means the G0 means the rapid traverse. At that time, there is a no cutting. Okay, so in addition, some more functions like M, S and T can also be given in the same block. Okay? So the instructional block with G00 will move the cutting tool and or the workpiece to the position with the coordinates given in that block at the rapid feed rate. Okay, so all the movements are executed at rapid feed rate. It should be ensured that before the start of rapid movement, the cutting tool position is such that it will not hit the workpiece during this movement. Okay, so G00 is the model function. Okay? G00 is a model function. That is the, if a number of consecutive blocks with rapid traverse are included in the program, then G00 is written in the first block only, and it remains active in the subsequent blocks. So this is the rapid traverse G00. Then next one is the G01 is the linear interpolation. That is the feed traverse. So any machining along the straight line, including taper line, is done using the linear interpolation function, and it is G01. Okay. So the general format for this linear interpolation is written like this. Okay. And then absolute or incremental. Then G01 is so the linear interpolation. Then X, Y, Z, feed, and some other miscellaneous functions also. Okay. So this syntax or this instruction block will move the cutting tool the position specified by the coordinates in this block. Okay. So the feed rate at which the cutting tool is required to move is also specified while using this G01. Okay. So however, if the feed rate has been defined in one of the previous instruction block, the same feed rate will remain active in this current instruction block also. Okay. So now this G00 and G01. Okay, in writing the instructional bus is now here. Let us understand with one example. Okay, so here you can see the point 1, 2, and 3. Okay, and here this is the 00. Okay, so starting point is 00, and tool is 20 mm above the job. Okay, tool is 20 mm above the job surface, right? And machining is to be done along 1, 2, and 3. Okay, so machining is done along this 3 point 1, 2, and 3. And Z is 0 is at the surface of workpiece. Okay, so Z is 0 at the surface of workpiece. And depth of groove is 3 mm. Okay, depth of groove is 3 mm. Now let us see how to write. So first N1, G90, okay, G71, G94, M03, S800, and end of block. What does it mean? So G90 means the absolute mode, G71 is the metric mode, okay, G94 is the feed in mm per minute, and M03 the spindle start at S800 means the 800 revolution per minute in clockwise and end of block. Okay. Then next one is the N2, G00 means the rapid traverse. Rapid traverse X10, Y30 end of block. Okay. So it means what? From the starting point 00, the cutting tool moves at rapid feed rate to point 1. Okay. Here you can see the cutting tool, it rapidly travel to this point 1. Okay. With no change in Z coordinate. Okay. So Z coordinate are written here. So no change in Z coordinate. Then what happened? N3 G00 Z2. Okay. So it means in rapid feed rate, the cutting tool moves to the point 2 mm above the job surface. Okay. At the job surface, Z is 00. Then it will goes 2 mm above the at rapid traverse G00 means. Now here N4 G01 means the linear interpolation. Z minus 5 F200 end of block. Okay. So here in linear interpolation, the cutting tool moves to the depth 3 mm inside the workpiece. Okay. So now here in this case, you can see the Z coordinate is 2 mm above the surface. Now we have to drill the hole 3 mm inside. So that's why at the surface that is minus 2 and inside the surface that is minus 3. So minus 2 minus 3 is minus 5. So that's why here Z is equal to minus 5. Then N G01 X30 end of block. So linear interpolation, the cutting tool moves to point 2. Okay, then X50 Y45, that means the linear interpolation, the cutting tool moves to point 3. And G00 Z20. Okay, so the tool moves to a point 20 mm above the job surface at rapid feed rate. And here again G00 x minus 10 y0. So move to point x minus 10 to clear the job for loading and unloading. Okay, then finally program end. Okay, so by this way you can write this program for linear interpolation. Then next one is the circular interpolation. Okay, so in circular interpolation, if the cutting tool is required to move along an arc, okay, a circular interpolation functions, that is G02 or G03, are used to execute the instruction. Okay, so the G02 is used if the direction of interpolation is clockwise, and G03 is used for the counterclockwise interpolation, right? So you can see the two formats are there here, G02 or G03, X, Y, Z, then I, J, K, then feed, okay, for using the arc center, okay, and here X, Y, Z and R using the arc radius, okay, you can use. So this arc center is specified by address I, J and K, okay, I, J, K, and then I are the X, Y and Z coordinates of the arc center with reference to arc starting point, okay. So you can see here G02 moves along the clockwise. Okay, so I, J and K. You can see here this I, J and here K. Okay, radius is given. And for the counterclockwise motion, okay, so for this counterclockwise motion, it is G03. So this coordinates of the center point of the arc are written in incremental mode, okay, with respect to the starting point of the arc, right? So this is called the circular interpolation. Now programming formats. So there are three programming formats. One is the fixed block format, tab sequential format, and word address format. Now here you can see the format is given here. So n is sequence number, j is preparator function, x is x coordinate, y coordinate, feed rate, spindle speed, tool number, miscellaneous function, and end of block. Okay. This fixed block format. So in this fixed block format, the instructions are always given in the same sequence. Okay. In this fixed block format, the instructions are always given in the same sequence. Then all the instructions must be given in every block. Okay. So including those instructions which remains unchanged from the preceding block. Okay. So for example, if some coordinates value, that is the x, y, z, it remains constant from one block to next block. Okay. So this value have to be specified in the next block also. So in this system, only data is provided in the program and the identifying address letters are not given, but the data must be input in a specified sequence, and characters within each word must be of the same length. Okay. Then tab sequential format. So in this format, or in this program format, the instruction in a block are always given in the same sequence as in case of fixed block format, and each word is separated by the tab character. So if the word remains same in the succeeding block, the word need not be repeated, but the tab is required to maintain the sequence of word. Okay. Then in word address format, okay, so each data is preceded and identified by its address letter. Okay. So for example, if X identifies the X coordinate, then F identifies feed rate, and so on. Okay. Now let us see one example. Okay. Here, if you want to drill the hole, okay, 10 mm diameter hole. Okay. Here. So N word 0 for hole 1, 0, 1, 0, 2. X word 15 for hole 1, 15, and for hole 2, 75. Okay, it's dimensions from this 0, 0. Y word is 20 for both. Feed is 200 and spindle speed is 500. Now let us see for fixed block format. So fixed block format, okay, this X is 15, Y is 20, F is 200, S is 500, end of block. Now it is repeated, you can see 20, 200 and 500 repeat. So that's why we have to write in all the blocks. Then in tab sequential formats, you can see each word is separated by tab, 15 tab, 20 tab, 200 tab, then 500 and end of block. Okay. And in word address format, okay, X15, Y20, F, it remains constant. So no need to write in another block. Okay. No need to write in another block. Okay. So this is the word address format. So now I hope you can understand very well. Okay. So in our next lecture, we will solve the different problems for the part programming. So thank you very much.